So what's that, Matteo?
Right here I've got a windlass, which is a wheel and an axle, similar to the windlass we have on the Chicago Boom. Actually, the same pretty much.
Okay. So how's it work?
Well, what's nice about having a windlass is it's kind of like a lever that you just constantly rotate around a point.
So it could be called a 360-degree lever.
Exactly. So, usually on a lever, we would take it from our pivot point to one end, pivot point to the other. On a wheel, it's a bit different, kind of the same though. Our pivot point is now the center of a pipe.
Let's see that pipe.
Like this one.
Good.
So we take it from the center of that pipe and go out to wherever the string is wrapped on the pipe, which is 1/2 inch for us.
Okay.
And then from the pivot point to where we use our hand to apply effort, which is 17 inches away. Same thing, it can be represented as a lever. So we just take 17 over 1/2. We get 34 for mechanical advantage.
Good.
Now, one problem comes up with having a string go around a pipe, and that's when you run out of room on the pipe, the string starts to wrap over itself. And what that does is, on this little diagram here, we have basically looking into the pipe. Here's our center point. These red dots are the first wrap, and the green ones are the second one. And you can see that on the second wrap, the string is now farther away than the first one. So instead of being just 1/2 inch, it is now 5/8 of an inch away. So we do our same thing, and 17 is the same, because we're still applying the force there.
Good.
So we take 17 over 5/8, and that gets us 27.2 for mechanical advantage.
Instead of 34.
Yep, so it's a little bit of a difference, but it's still notable.
Well, let's see how it looks on the crane.
Yep.
Wait a second, let me get lined up here. Okay, so
you can see it goes towards the end, and at some point it comes back and starts wrapping around itself.
it's a double wrap,
Yep.
so the decreased mechanical advantage.
Yep, because that little change in radius is enough.
There you go. Okay. Now on this crane with the Chicago Boom, we've got 4 parts of line holding up the load.
Mechanical advantage of 4.
So if the load, let's say the load weighed 100 pounds, and you were pulling right there, how much muscle would you need?
Only 25 pounds.
That's ideal. With all the friction, it's a lot less.
Yeah.
And then now we can include the mechanical advantage of the windlass.
Yep.
So the pipe,
It's still 1/2 inch, or inch diameter, so
Yeah,
1/2 from the inside to the
the
outside.
first wrap, so that's
Yep.
1/2 inch, and the diameter of that is, I think,
Or radius of that.
the radius is, let's say 4 inches.
Yep, okay, sounds good.
So 4 divided by 1/2,
8. We'd have a mechanical advantage of 8 in pretty much perfect conditions.
so mechanical advantage of 8, and this was a mechanical advantage of 4.
Yep.
Do we add them?
No, we multiply them. So we take mechanical advantage of 8, times it by 4, that gets us 32.
Right.
Mechanical advantage of 32 in this
That's the
whole
idea.
system.
Ideal. Now with all friction, it might be
28, 27,
whatever
somewhere
it
around there.
is. It's better than not having any mechanical advantage at all.
Yep.
Okay. So to get a mechanical advantage of 4, we have 2 shivs or pulley wheels. Put that one in there for me. Okay. Now everybody calls the wheel a pulley. It's a pulley wheel. A pulley is actually, hold that one up for me.
Over here?
Both of them, yeah. Higher. Yeah, just,
Oh.
there we go. Okay.
There you go.
So there's a pulley